you right now is after the introduction from my colleagues and the explanation about why to invest efforts on this. It's a clear example in a highway, in a study in 70 kilometers track of highway in Spain, for transport infrastructure. Okay, just to give you an overview, where is located. Okay, it goes from near Madrid. It's about 35 kilometers away from Madrid, and it's the main communication highway, let's say, in between Madrid and Barcelona, which is located here. Okay, so it's just the main well, traffic connection, and there's no other alternative at this point, at least with this traffic capacity right now. And well, how the methodology was designed and was also previously explained by Dennis in the clarity approach, and also by Laura about the needs of this type of research in transport infrastructure, and also after explaining by Ernesto the climate indexes that we have been used to calculate this into the tool. So we well, also the well, this is the system, how it looks like. Okay, the website. So we have 5 different steps. Okay, as it was already previously mentioned. We have to, when we have a transport infrastructure, first is necessary to characterize the hazard, to evaluate the exposure, to make a vulnerability analysis, and to make a risk and impact assessment. Okay, so first, how we have been worked with this track, highway track. Okay, we firstly worked with the people from the maintenance service of the road. So this is a 2 lanes highway which goes from Guadalajara region to almost to the limit with Soria, in the middle of Castilla-La Mancha and Castilla-León, which is a region in between Madrid and Spain. It's a rather high altitude highway. It begins in the first kilometer of track at nearly 800 meters of altitude. That it ends at the kilometer 135 at more than 1,200 meters of altitude. So the winter maintenance, it's a key issue in this track. So we mainly went through the road design and identifying the possible spots where the exposure. So the exposure analysis, we went through the slopes and different asphalt characterization and possible problems according to the experience of this track and the people making the maintenance of this track from the previous year. So we identify different overpasses or down passes of the highway. All the drainage systems have been identified and have been spotted into a table. Okay, we identify it, we describe it along the highway, along the track, talking with the engineers, with the designers, and with the responsible of the maintenance. So this is the final part of the concession. So it's a rather high traffic intensity road. Okay, so once the exposure analysis has been done, we go to the tool. Okay, and the tool let us also characterize each of the tracks. Okay, let me put this down so I can manage. And here in the system, we can plot out a map with the all identified points. So this is the track that you have seen previous in Google Earth, which is rather more visual. And I'm going to choose another map, okay, because it's better to understand. So this is again the track. And the system allow us to identify each exposure point, possible exposure point. Okay, so how to identify and how to add a new exposure point in our track, for example. So we went to the exposure evaluation step. Okay, again, the map has to be loaded. Let's go to the, okay, and we can make a zoom. And for example, so we have identified here different bridges and different infrastructures of the road, which may have of interest making the analysis. Okay, so we can identify different type of infrastructures and different point of vulnerable points. So we can identify drainage or drainage rivers, different type of tarmac or pavement infrastructure, linear drainage, transversal drainage, overpasses or down passes, or even different type of slopes. Okay, or even we can identify in this case, because it was also an open issue, different types of winter maintenance points, where, for example, we have accumulation of snow in a certain point, of accumulation of ice due to the a shadow zone or whatever, according to the system and to the experience of the maintenances. So we can, the system allow us to identify one specific point, like for example, I'm going to make an example to create, for example, one, well, let's say one of these, for example. So we can identify it's in the kilometer point, let's say 75, and it's a drainage system. Okay. Okay, so we can, let's see where the system creates the, so the systems
in the not in the bottom, but in the upper.
Here, okay. We can identify here, for example, one line. I think it's already created somewhere in the map. Okay, let me see where it is. Okay, here. Well, somehow we are allowed to create different type of vulnerable points. Okay, and we can later here. Let me see if it's this one. Well, we can. A ver, que estaba un poco lento. We can identify in the map. Okay. And even we can identify in a table. Okay, so we have identified all the exposure points, for example, according to the type of infrastructure. So, for example, in the case of slopes, we have different slopes created at different kilometers along the study track. Okay, we can erase them, we can modify them, and or add some information about it. Okay. Slopes, river flows, different type of platforms or tarmacs or asphalt pavements. Okay, so and identify different problems. For example, not enough drainage capacity, or problems by intense rain or heavy rain, or identify, for example, physical problems of the pavements, where deformations due to heat waves or deformation to the elastic behavior of the pavement. So different, again, transversal drainage, identifying different points along the road, So the system allowed us to make groups of elements along the road, and also this is the winter maintenance. For example, it's in Spanish, but well, the different points of winter maintenance problems identified along the road, and which are positioned in each. So we can identify them in the map, okay, as I already showed you. For example, here with different points, and in the table, okay. So the first step, which is the exposure evaluation, it's already done. I mean, because in this case, in this example, we have all the points already loaded into the system. And the second step will be the hazard characterization. So we have identified the points along the road which may have problems due to the different type of climate hazard, okay, which has been already identified and also explained. Let's see the map. I'm going to show you how the maps works, okay. And also, as previously explained by my colleagues, by Ernesto and Laura, and according to the type of infrastructure, why the map is not loading? So the map is supposed to load maps. Okay.
Just wait a moment. I suppose it's going to
load. It takes time.
Sometimes.
Yes. Yes. Okay. Here we are. So we have identified the exposure points, the possible exposure points, and then right now we're going to make the hazard characterization. So which is the hazard? The hazard are the different climate indexes that we have defined, which may be important in a transport infrastructure, and which are them. So here we have them. So all of them dealing with precipitation, mainly heavy rains, and periods of also intense wind. Okay, we're talking about an infrastructure, but in this case, in this specific case, the wind is not so important, but maybe in others could be of interest. So included also one climate index regarding wind, strong winds. So mainly maximum daily temperature, percentile 5 of minimum daily temperature, thermal amplitude, precipitation, maximal precipitation in 24 hours, maximal accumulated precipitation in 5 days, and maximal consecutive days with precipitation. Okay, so all of them for two climate scenarios, for the RCP 8.5 and RCP 4.5. Okay, so we identify climate indexes regarding precipitation and regarding temperature mainly. So for example, if we select for example maximum daily temperature, this one, so the system get the values, okay, from each point along the road and give you an overview of the well, in this case it's in the year 1970, okay, so past climate, but we can move along this bar up here, and we can move along the years, so we can have estimations. Okay, so we can see here we have higher temperature down here because mainly due to the issue that I explained before, that here we are at lower altitude. That here we are talking about almost 300 meters difference of altitude in between this kilometer and this kilometer. Okay, we're talking about 70 kilometers distance, And if we move just to have to check the variation. So here you can see how the colors are changing, and we are getting higher temperatures in the estimations due to the climate change and specific for this climate index, which is the maximum temperature. And if we will move forward to year 2040, come on here. So the systems again calculates, takes the data from the base data where this percentile of maximum temperature is calculated and plotted into the system. Okay, and if we move forward to 2070, okay, which is along the years, okay, we can feel the difference very good, okay. And for example, if we plot this all together, like for example in this slide, let me see if I can plot this to the big screen. So this is the percentage of maximum temperature, daily maximum temperature 1970, 2010, and 2040 for the RCP 8.5. So we can have an overview along a rather quite large track, let's say, and we can think about how this may affect the infrastructure or not in the case of the temperature, okay? So this is very good, okay, it's very visual, but we can also have the same data for each specific point. So if we go back to the table where all the previous points were tabulated in a table, okay, and we select the percentile 95 of maximum daily temperature, okay. So for each identified point in the map, the system calculates, go to the base data and comes with the data for the specific temperature in that point, in that kilometer, for the different period scenarios from 2040 to 2070 and well 2000 the year 2100, okay. So we can have the system allow us to have an overall overview for any specific climate index that we have previous calculated, okay, as was explained by Ernesto, by Ahmed. And right now, for example, I'm going to show you the precipitation, okay, maximal precipitation in 24 hours, for example, this one. Here we have the scale, the colors scale in millimeters day, okay. And let me see, okay, again. So I think you can feel the difference. So we have lower precipitations here, higher precipitations along as we are moving high in the mountains. But for example, if we go to the estimations for 2040, so we are going to have more intense and heavy rains all along the road, okay, and even in 2070. So it seems that, for example, if we have right now, if we in this track we have some drainage problems, or the drainage of the pavement in certain points, it's rather problematic right now. If we continue with the same type of pavement and or the porous systems or the drainage systems are not well maintained or well repaired or even increased, we may have more problems along the years, okay? Because it seems, according to the estimations, that again, if we go to the table, just to have a specific overview of each point, okay, the systems goes to the base data and comes again with the data of how this is the maximum temperature. I'm going to plot, sorry, the maximal precipitation in 24 hours, okay. So we can, for example, if we go to the drainage systems, okay, here, for example, let's wait to the systems to calculate, to come back with the data. So we are going to have, for example, you can see this example. So we are increasing from 29 millimeters to 34. Well, it's not a rather big increase in precipitation, but it's something that we have. I mean, the maintenance people and the people from the road maintenance or the truck system maintenance must be aware of. Okay, so again, so we have the step one. We have the exposure evaluation, the hazard characterization, and then the system allows us to make the vulnerability analysis. Okay. So again, and also as previous explained by Laura, in this case, there are not an specific. We haven't identified a specific formula or simulation for the vulnerability analysis, and we the system. We decide to design a system according to the, like, for example, in this case, it's a track, it's a road. It's not a new design of a road, but it's a road which has been exploited during the last 10 years. Okay, so it's an open track, and we have data from the exploitation and maintenance issues. So the system allowed us to well, to characterize each element, each point, and we can define, or we, the designers, the engineers, or the road maintenance experts may make the exercise to define the vulnerability. So for each point in the map, which we have previously identified in the map, in the table, and also in this table, we can define the integrity of the specific infrastructure from 0 to 6. So from inexistent 1 to very important 6. So we can define the severity and the probability of the issue to happen in this specific point. So from 1 very weak to occur, and 5 it's very probable to occur. So so we can define also the integrity of the element along the years, and according to the data, to the climate data that we have previously analyzed. So we have to look into, to make the previous exercise, which is we have all the elements of the road. We have analyzed them with the hazard characterization, and we, I mean, the expert criteria decided if the integrity and the severity of the exposure to the climate index, specific index, is rather severe or weak, and along the year. So for the different period scenarios in years, so from year up to 2040, 2070, and or to 2100. Okay. And even though the system also, depending on the, we have defined what is called the traffic conditions operation, or traffic operation conditions. How the integrity of this element may affect the traffic conditions. Okay, so and how may affect the severity and the probability to occur. I will explain this better with a picture from the road. Okay, for example, if we go to the first point of the track, for example, here we have identified several exposure points, like for example this slope. Okay, we have here a slope which has been identified, and it's a slope which is with a rather, let's say, erosion soil, okay, which may have problems. But how this may affect, or if this soil collapse into the road may affect the circulation. Well, for example, it may not cause a big issue into the circulation, as it is not in the main track of the road. But for example, if we go to this one, okay, this other one, which is in another specific point, okay, what may happen if this slope collapse or part of it collapse into the due to the or heavy rains or mainly not a good drainage of the system and so on. Well, was here the affection to the traffic or to the circulation, it's much higher. So this is also the system allow us to identify it and to define, for example, here. Okay. So we can identify the severity and the probability to occur for each specific action area. And well, and the next step in the system, the fourth step, the system calculates according to the climate evaluation and according to the data that we have introduced in the table. It creates a matrix, okay, where each element of the road has been identified and the risk assessment is being calculated from high, medium, low, or negligible, okay, despreciable in Spanish. So the system plot us for each specific point of the road, and according to the climate indexes that we have calculated and we have identified to be important in this type of transport infrastructure, okay, how these elements are being identified due to the risk and climate risk impact and assessment, okay. Again, the system allow us to plot the systems in a table, or we can have a look to the track, okay. I'm going to plot the other map where we have a better view of the system. So for example, in this case, and according to the type of exposure point that we have defined also here the system plot us different colors where the risk is medium, high, or low, okay, red for high risk. In this case, here we have the pavement in red because we have identified here the winter maintenance issues and also the drainage systems as you can see from the beginning, okay, that we are going to have more intensive rains along the years in how is the predictions coming on. So here the system tell us that we must take care of the drainage systems or the winter maintenance systems along the road apart from kilometer, whatever kilometer, okay, here. So it makes differences. So you can identify or you can make an vulnerability assessment of in a map or in a table as it was plotted here, okay, for each point of the road. So, and to finalize, the last step of the methodology and the last step of the system is just to propose different and to identify the different adaptation options, try to mitigate the possible risk identified according to different climate indexes that has been studied for this type of infrastructure and for this specific track. So the system allow us to propose and to identify different adaptation options according to the type of infrastructure. And in this case, and for the traffic issue, we are working on incorporating to the system different let's see here, different adaptation options according to different identify problems regarding slopes, regarding drainage incapacity, or regarding well, problems of mainly those type of problems has been identified in this highway track infrastructure. So we are on the way to incorporate this into the system, just to evaluate, and to model how these adaptation options may decrease the risk in this type of infrastructure. Okay, and I think I made an approach from all these 5 steps of the system. I think that that's all from my side. I mean, the system has the powerful to analyze different climate indexes along a specific highway track. It's also valid for road infrastructures and also for railway infrastructures. I don't know if you were planning also, Luis and Dennis, to make an approach to the railway example, but as I think we are behind schedule, I think we can. Well, this is all from my side, I would say. We cannot hear you, Dennis.
Yeah, that's because I was muted. Okay. So thanks, Chaim, and please, the rest of you, could you join us? Hey, Chaim, come back. We have the final discussion. Laura,
okay.
Ernesto.
Just a few remarks. The information we have seen with José Cubillo is it's handwritten all in Spanish, but the system allows you to show the information in English. It depends on the configuration you have on the browser you have. So all information is in English if you're not Spanish. Right now there are only these two languages. Let's say the Spanish and English, but it's quite easy to incorporate the new idioms into the system. The information for Spain is based on the information that IMET has calculated in the project, but the information for all over Europe is the information that the Meteorological Institute of Austria has calculated in the system.
Okay, thanks. Now, I think one thing is interesting to mention. When I compare this traffic application, the screening with the urban screening, what I notice is that on one side, traffic application is, let's say, more appropriate for really using it in daily work. It's more aligned with the way the engineers work. But on the other hand, it's doing less actual calculations. So in this traffic application at the moment, it's mostly, I mean, it can be, in my opinion, described in a short term as we show the engineer in charge of road what they want to see. And then it's up to them to decide what is really the part which needs more attention or not. And the system will happily accept their input and make it presentable in a printable form as a report in the end. Is this correct in your opinion as a current status of work?
Yes, I think it's correct in my opinion. I mean, in the urban screening, we have developed a thorough tool in order to calculate the vulnerability of the different elements. Here we are based on the opinion of the engineers that maintain the road. There is not vulnerability functions, but there is not vulnerability functions because there is quite difficult to do to define vulnerability functions for the elements of a road.
I think the difference is that we have a lot of possible vulnerable elements with very different typologies, and also we have a wide range of impacts. However, I think we have to continue working on the giving some hints to assess the sensitivity we were talking previously.
Yes, I hope that we will manage to start some exploitation with what we have now. It seems to be quite useful. And for the future, it would be really good if this would be then extended with some hints. And I really say hints because looking at what we learned in the project, just saying, okay, this is how it is to the experts, it's probably not the best approach. But telling them, well, you know, we believe that this is slightly or very much sensitive to rain or to freezing or to high temperature. But if you don't believe so, you are able to change it and then let us calculate what the results are. I think that this is probably the best approach for the future. And in addition to this, we discussed already sensors. I mean, the reality is as it is, and we can always approximate it by models. But in the future, we will need to incorporate the results from sensors to see how near or how far we were from in the last round, and then improve based on that. And I think in that way, with the time, we can make a really amazingly good tool from what we have at the moment.
I also think it's, I would like to point that it's important to count with a good expert panel to do the assessment, someone who really knows the road. But also if you want to do a more detailed analysis, it's good to have people who knows from drainage and people who knows about geotechnics, and this will give more support to the assessments.
There was actually one among these questions which was like, well, from my old friend Mark, like, hey, but what do you do with debris? Because in certain configurations, the debris will come down the hill, and this will be the main problem you have. And I think that modeling this is relatively difficult. You have to model on a very, very tiny scale. But knowing where the debris will come, because that's where it comes every year, is something which is probably much easier. And so it can be taken either from existing knowledge of the expert or from sensor measurements. And that way can be then combined with the simpler models.
Yeah, I agree with you.
Jaime, famous last words for you.
Well, I hope that we achieved to explain the powerful of the tool. I think, especially regarding for traffic infrastructure for roads which are already built and are also exploited, it's a good methodology and tool for make the assessment. That just to mention also, at least in Spain, the regional administrations are starting to be aware of this. Vulnerability, risk and vulnerability assessment of due to climate change in infrastructures, and I hope that this tool may help to make these studies regarding the regarding the possible impacts of different climate indexes, at least the ones that we have reported here, could be used for make estimations and try to redesign some part of this transport infrastructure if needed. Okay.
I think that's it. There is. Let me see if there are any new questions.
No, I don't think
just
so.
Some comments from people thanking us, and that's it.
Hmm.
Good, then I would say thanks everybody for joining us. Thanks for the presenters as well, and hope to see you on another webinars of ours.
Thank you. Bye.
Okay.
Bye
Thank
bye.
you.
Bye bye.
Ciao.